Welcome to solverfy.
Okay, we have cyclohexane, the CH2 and a bromine sticking off, reacting with sodium hydroxide to give the same thing, but hydroxide replacing the bromine, and then a side product, which you don't really need to worry about, of sodium bromide. We need to draw a transition state for this, knowing that it's an SN2 reaction. And so the way we do that is we can redraw the molecule exactly as it is, but where we previously had a bond between carbon and bromine, we'll draw that as a dotted line. And then where we're going to get a new bond to this oxygen, we'll have that as a dotted line. Okay. The charge on our hydroxide, right, because this is sodium plus hydroxide, it exists as an ion. Okay, so this shows our hydroxide coming in and our bromine leaving. The final thing we do is that we put it in brackets to indicate that it's a transition state. Well, we put it in brackets and we add this little double dagger. It's a line with a line at the top and a line near the bottom. It's a double dagger, and that represents transition states. Sorry, and one final thing is that rather than putting a charge on the full charge on the oxygen, will show that it's partially negative, that the carbon is partially positive, and the bromine that's leaving is partially negative. And the way that you do that is you look at, in the previous step, what was the charge on hydroxide? It was negative. And then in the final step, what was the charge on hydroxide? It was neutral. So it's got to be somewhere in between negative and neutral, and we represent that with partial negative. Likewise, for bromine, it was neutral in the starting material, but existing as an ion, sodium plus, Br minus, in the final product. So it's got to be somewhere between neutral and negative. We call that partially negative. And in fact, I noticed a mistake. The carbon is neutral in the starting material, neutral in the ending material, final product. So this shouldn't be charged. It should be the average of the two charges. The average of neutral is simply neutral, right? Two neutral things averaged out would just be neutral. Okay, so that would be a transition state for this reaction. We can repeat the same for our next reaction, right? We have iodine reacting with acetate. We're left with iodide. Again, we'll show the new bond forming between this oxygen and this carbon, and we'll show the iodine leaving. So I like to draw it exactly as is, but replace the bond between our leaving group and carbon with a dotted line to indicate that it's leaving. Okay, and then we'll show a dotted line to the new nucleophile, like so. Put the whole thing in brackets and add our double dagger. Then we'll look at the charges. Okay, in the starting material, we've got negative on the oxygen, but it's neutral in the final product, so this should be partially negative. The carbon is neutral to begin with and neutral to end, so it should remain neutral. And the iodine starts neutral but ends negative, so it should also be partially negative. Okay, next one. Chlorine, sodium hydroxide. Remember that exists as sodium plus NOH minus. And it's going to give us an alcohol and sodium plus and Cl minus on the side. Same idea, redraw it, dotted line for the hydroxide coming in. Put the whole thing in parentheses, add our double dagger. Average of negative and neutral is partially negative. Average of neutral and negative is partially negative. All right, last one. Got bromocyclohexane reacting with, again, we'll break this up into sodium plus and SH minus. You don't have to put the circles on there. I just do it by force of habit sometime, but it's fine to not have them on there. In the end, we get this thiol and sodium bromide. Let me draw this sulfur a little better, make it more obvious. It's the thiol. There we are. So same idea. We're going to draw a dotted line between the carbon and the bromine to show that the bromine is leaving. Okay, we're going to have sulfur with the hydrogen attached, and it's going to be coming in, so we'll draw a dotted line there. Put the whole thing in brackets. And let me draw this S. It got a little cramped, and so it's not. There we go. SH. Okay, look at the charges. Sulfur starts negative, ends neutral, so partially negative. And then bromine starts neutral, ends negative, so it's partially negative as well. Okay. Next, we've got a 4-carbon chain with a fluorine attached. We know there's got to be a hydrogen in the back, right? Because carbon must have 4 bonds. We're going to want to number the chain 1, 2, 3, 4 to give the substituent, in this case fluorine, the lowest possible numbering. It's a 4-carbon chain, right? So that would be butane. We know that's the root name. We know there's a fluorine on carbon 2, so that's going to be 2-fluoro. Okay, and then we need to determine whether it's R or S, right? So fluorine is the highest priority group. Next is a 2-carbon chain compared to a 1-carbon chain, and then hydrogen in the back. If we connect 1 to 2 to 3, that's counterclockwise, and when hydrogen is in the back, or the lowest priority is in the back, that corresponds to S. So altogether, that is answer C. All right. Finally, which of the choices is secondary alkyl halide? Meaning of a secondary alkyl halide is that you have a carbon with 2 bonds to carbon, and then some sort of halogen attached, which could be chlorine, bromine, fluorine. So here's an example. Actually, our previous molecule is also an example of a secondary alkyl halide. So we're going to take these structural formulas and turn them into bond line drawings. Okay, the first one we start with has CH3, 2, right? That implies 2 methyl groups sticking off. Okay, then a carbon with a single hydrogen attached. Okay, and then that connects to a CH2. And then there's a chlorine. Okay, so if we were drawing this as a typical bond line drawing, it would look something like this. Okay, that's not a secondary alkyl halide because the carbon which bears chlorine only has 1 bond to hydrogen, so it's a primary alkyl halide. Okay, next we have our 2 methyl groups sticking off. Then we have a CH. I'm not going to draw the H. Oh, sorry, we don't have a CH. We have a CCl. So I will draw the Cl sticking off. Then we have a bond to a CH2 and a CH3. So it's the same molecule, but we've moved the chlorine over 1. And we'll notice again that, yes, it's an alkyl halide, but it's not secondary because this carbon is a tertiary carbon, 3 bonds to carbon. So it's not B. We'll look at C. Again, we start with our 2 methyl groups. Then we're saying it's attached to a CH, and that CH is attached to a CHCl with a methyl group sticking off. Okay, so now, finally, we have a chlorine attached to a carbon, which we would classify as being secondary, which would mean that this is a secondary alkyl halide. Okay, and then the final molecule, again, we have our 2 methyl groups. We have a CH. It's attached to a CH2. And that's attached to a chlorine, but also 2 methyl groups, right? Which implies that this is a tertiary alkyl halide because the chlorine is on a carbon with 3 total bonds to hydrogen. So the final answer was C.